Hi, my name is Kyungmin Lee. Today I'm going to propose our vision and approach on managing user attention as a resource in mobile systems. So there are two emerging new trends in how we interact with mobile applications. The first trend is that people are increasingly using mobile applications while performing other primary tasks. People are walking and checking emails. People are using mobile GPS applications to navigate throughout the roads. And this is different from a traditional desktop environment and app interaction where user has full attention focused on the application. But in this mobile environment scenario, that mobile application interactions are usually ancillary to what user is primarily doing. The second trend is that applications are continuously run in the background and they try to interact with the user when it believes it found some useful information to share. And the fundamental problem that arises from these two trends is that the mobile applications assume that it can claim all of users' attention, but in reality, the user might not even have some or might have none of the attention to spare because users' attention is mainly focused on other primary tasks. So mobile app interaction is very useful if it gets delivered in a right context. So here you have a smartwatch and you get a notification saying, email notification from your friend about the party that you're planning. And if you're driving and in a serious meeting, you probably don't want to be interrupted with this interaction. But if you're in the home, bored and flipping through the channel, this type of interaction might be something that you want. And if you're listening to my talk right now, depending on how interesting you find my talk, it may be appropriate and it may not be appropriate. Unfortunately, the application is completely unaware of users' context, and they're trying to interact with us in all these different scenarios. So what is the existing solution to resolve this problem? Currently, mobile systems that put this burden on the user and let the user decide. So user can set policies for each applications to deny or allow our interactions based on the application space. Or depending on the user's context, user can manually disable all interactions across all applications. And unfortunately, this approach is too coarse-grained because it just provides all or nothing. And from our personal experience, that we know this does not really work because how many times we get buzzed by our mobile phones when we don't want to. So what we're proposing here is we want mobile operating system to be a little bit smarter than just enforcing coarse-grained policies set by user. What we want mobile OS to do is we want to extract users' context from various mobile sensors such as GPS, accelerometer, microphone, and etc. And with this user context information, the OS will make decision on whether to deliver the interaction now or modify the format of interaction or defer the interaction later for the more opportune time. And we believe the OS is the right place to perform this job for two reasons. The first reason is that extracting user context requires for us to access various sensitive mobile sensors. And the OS is since already trusted with accessing this sensitive data, we believe this is the right place. The second reason is that the OS has been traditionally known for managing various resources such as CPU and memory. And since we're transferring user attention as a resource, we believe this is the right place for OS to perform the job. So here's going to be the outline of today's talk. I'm going to propose our vision scenario, what we want to achieve. And I'm going to propose one approach that we think it could work and discuss some challenges in achieving that. So let's look at the scenario here. So here you're driving in a very snowy weather at night. This is typical weather in Michigan, and you get a text message from your wife saying, "Can you pick up the milk?" Normally, this text message might be important for you, and you probably want to get this interaction. But since the road condition is so harsh, and you're driving and your tires are slipping, it probably is a wise thing not to interrupt the driver at this point. Suppose we're in the same scenario, but we have a crowdsourcing traffic alert app running on our mobile devices, and then this application alerts us that there's going to be a dangerous road condition ahead. And in this scenario, because this could be a life or death situation in the later, we probably want to interrupt the user about this dangerous traffic road alert. And we probably want to do it in an audio interaction so that we do not overload users' visual attention. And later when we are off the highway and let's say we're stopped at the red light, and now since the user has some of the attention to spare, this will be the right time to deliver the interaction that we decide not to deliver at the first time. So in order to achieve this vision scenario, what we're thinking about doing is we're going to manage user attention as a resource. So we want to treat user attention in a way that OS already knows how to treat it. So we want to transfer this into multi-resource scheduling problem. So for given a user activity, first of all, we're going to break down attention level into various dimensions of attention. So we're going to break it down to visual attention, auditory level, cognitive, haptic, and etc. So given a user's current activity, we can break down how much of this individual attention demand that user is currently consuming. And when along with that, we want to know how important this current activity is to the user, and we can determine that through a priority level. And so this is our current baseline consumption of users' attention. And now we have this mobile application who want to interact with us, and that also has some sort of attention demand that it's going to impose upon us. So that's going to be shown on the bottom of this slide that, so for each interaction, we want to break down the attention demand in the same way we broke down the available user's attention level into these various dimensions. And we're also going to try to extract how important the priority level of this interaction. And we'll try to we'll try to schedule this in a way that we want to maximize the priority without completely overloading users' available attention. And depending on how important and how available resources that we have, we may choose to deliver the interaction now or modify the format or defer it for later. So I'm going to go through our approach by going back to our scenario again. So remember the scenario where you're driving in a very harsh road condition at the night. So the priority level for this current activity, we're going to assign this is going to be a high priority because you're driving and that is very, very important primary activity. And we're going to break down the attention level of this activity, and since user is driving, user is probably consuming all of the visual attention, and the user is probably consuming good amount of the cognitive attention. And now we have this text message from a wife, and we're going to assign this as a medium priority, and we're going to look at how much of attention demand that each of this is going to impose upon. So since this is a text message, it's going to require for a user to read it, so it's going to consume some of the visual attention, and it's going to consume some of the cognitive attention demand because it requires user to parse the text message. So let's see what happens if we actually deliver this interaction at this current context. As you can see, since users was already consuming huge amount of visual and cognitive attention, and we're loading on top of that more demand, it's going to overload users' available attention. And since this interaction we assign to be a medium priority, and this is a lower priority than users' current task, which is driving, we're going to not deliver this interaction at this moment and wait for more opportune time to deliver in the later. And now back to the scenario where we have a different alert system, which is a traffic alert from telling us that there's going to be a dangerous road conditions ahead. This is really very high important priority. It's relevant to your current activity, and so although this is very important interaction, it still overloads our user attention in a pretty significant way. But we want to deliver this interaction because this is higher importance than what users' current primary activity is. So we want to deliver it in a way that we minimize the overload. And what we can do is we looked at the modality. So this is where we're going to change the delivery format. So instead of delivering this dangerous road condition ahead alert as a text alert, we can change to the audio modality so that the user is no longer need to consume additional visual attention and just need to consume some of the auditory attention, which user has a lot to spare. This is still going to overload users' cognitive available attention level, but we believe that since this is a very high important interaction, we are going to overload it and still deliver the interaction. And lastly, now we're at the lastly we're at the stoplight, we're at the red light, and we're no longer on the highway. So the user's cognitive attention load has been dropped, and user's visual attention load has dropped a little bit. And now, since noticing this attention drop, we can now decide to deliver that deferred text message from your wife at this moment. Since I illustrated one of our approach, I'm gonna start talking about, highlight some of the challenges that we think we're gonna encounter and some of the way we want to resolve these challenges. The first challenge is that how can we determine the priority level of an interaction and how important this interaction is to the user. And if you look at the the application actually has some idea of how important certain interactions is. So Gmail does a pretty good job of filtering your email. It filters your priority email and filters out your spam folders. And as an application developer, they have some local idea of how important this interaction is going to be. But unfortunately, this application's view is not necessarily true, not necessarily same as the user's perspective. So for a user who don't really care about social network, the Facebook notification might be just a low priority, and email from a colleague is actually a higher priority to the user. And how can we determine this priority of interactions priority for a user base is a challenge for us. And a couple of approaches that we're thinking is that one thing we can look at is how fast user reacts to a particular interaction. So for a high priority interaction, people tend to click the interaction fast and try to respond to it as quickly as possible. And for some low priority interaction, people will just tend to look at it and take some time to do other stuff, and then when they feel like they want to respond it, they can interact with it later. And so we can take a look at the response time of the interaction as one of the measurement to measure the importance level of interaction. Another thing that we can do is we can periodically ping the user at some time, then asking them to say, was this interaction, how important was this interaction to you, and build those and learn from the user from these surveys. The second challenge is that how can we measure interactions attention demand, and this is pretty difficult as well. And what we're thinking about doing is we're going to assume that the previous interaction, future interactions will resemble what the previous interaction will be. So if the previous interaction requires some amount of attention demand, and we're going to assume that the future interaction of the same type will going to probably demand the same amount of interaction. And so what we're thinking about doing here is we're going to extend our previous work called AMC, which was presented in Mobisys a couple of years ago. And the AMC is an automatic toolkit that automatically explores Android applications to find UI violations as listed on the right side of the slide. And so for instance, in this case, this application has a lot of words on the screen, so it is inappropriate to be used in a driving scenario. We're going to extend this work and change the two things. So first thing we're going to change is instead of in AMC, the application, it was an automatic toolkit, but instead of the toolkit being a driver, we're going to make a user a driver of this, and we're going to perform online learning and profiling as user interact with the interactions. The second thing that we're going to do is instead of finding this threshold based violation or no violations for particular criteria, we're going to go a little bit further, and we're going to change the AMC to a measurement-based, quantitative measurement-based approach. So when the word count violation occurs, we're not going to say there has been too many words. What we're going to do is, since there's too many words, we'll say it's going to consume a lot of visual and cognitive attention because of that. The last challenge that I'm going to highlight today is how can we estimate users' attention level. So, and in Mobisys or Ubicom, in a lot of census community, that there has been many researches done on activity sensing, and we're thinking about leveraging those activity sensing to figure out, using various sensors, what user is currently doing. But unfortunately, the simple activity sensing is not enough. So if you look at here on the top, on the left, on the top, you have people cheering for Super Bowl or their team in the Super Bowl. On the bottom, there's a lady who's just flipping through a channel. although it's from the activity sensing, it might come out that people are watching TV, their engagement level is completely different. And thus that affects how important current activity is to the user. And we need to consider that. And unfortunately, as of now, we don't have a good idea of how to get this to it, but we're going to try to learn more about and do more research on this area. So today I showed our vision of delivering right interaction at the right time. And one of the approach that I proposed was that we want to treat user attention as a shared resource and determine the priority level of the interaction that mobile application wants to initiate, and the priority level of your current activity. And we're going to also consider what is available user attention supply and the demand that is imposed by an interaction. And we're trying to change this to a scheduling problem and manage the user attention in that way. Thank you.